Section 2.6, Proving Geometric Relationships. We are continuing with proofs this section, and essentially for the remainder of the semester, you will get better. They are tough at the beginning. They will become easier the more we do. So hang in there and let's keep working on them. So first vocab word is a flowchart proof. The 2-column proofs that we did in 2.5, where you did the statements and the reasons, that's one way to organize your proof, your justifications. There's another way called the flowchart, where you do boxes, and then you connect the boxes with arrows. And maybe you have 2 boxes that come into one box. And what goes in the box is the statement. And underneath the box is the reason. Now the words themselves, the actual statements and reasons, would be the exact same words and symbols that you would put in the 2-column proof. This is just in more of a picture form versus a list. A paragraph proof is another way to do a proof. This is with sentences. So instead of saying, what was one of the proofs here from section 2.5? AC is equal to AB plus AB. Your reason was given. You would say something like, AC is equal to AB plus AB because it is given. AB plus BC is equal to AC by the segment addition postulate. So you would include words like then, next, finally, first. Make it a paragraph. A couple more theorems. There are many, many, many theorems out there. You don't need to know them all. The more you know, the easier and faster it is to solve things. But by all means, you don't have to have all of them memorized. We have a couple here that are helpful but not completely necessary. So right angle congruence theorem says all right angles are congruent. So if angle A is right and angle B is right, then angle A is congruent to angle B. Right? Because right means that it's 90 degrees. So if angle A is right, then it's 90 degrees. So B is right. That means it's 90 degrees. They're both 90 degrees. So that means they're congruent. Saves a couple of steps for you in a proof. The congruent supplements theorem. If 2 angles are supplementary to the same angle, then they are congruent. So if angle A and angle B are supplementary, and angle A and angle C are supplementary, then that means angle B is congruent to angle C. But think about it. Angle A and angle B are supplementary. That means they add up to 180. A and C also add up to 180. The only way for A and B to add up to 180 and A and C to add up to the same number is for B and C to be the same number. They're congruent. The congruent complement theorem, same idea. A and B, angle A and angle B, are complementary or complements. Angle A and angle C are complements. Then angle B is congruent to angle C. Same idea. If A and B add up to 90 and A and C add up to 90, then B and C have to be the same size because otherwise they wouldn't add up to the same number. The linear pair postulates. If 2 angles form a linear pair, then they are supplementary. Let's call it 1 and 2. So angle 1 and angle 2 are supplementary. This last one, the vertical angles congruence theorem, this is one of the most important ones of the whole year. You'll use this first semester and second semester of geometry. And that is that vertical angles are congruent. Always. This is always true. So if I draw a picture with 4 angles, 1, 2, 3, 4, angle 1 is congruent to angle 3. Guaranteed. Always going to happen. Angle 2 is congruent to angle 4. Guaranteed, because they are vertical angles, and the vertical angle congruence theorem says vertical angles are congruent. This one is used a lot. Memorize that one right now. So example 1, find the values of x and y. What do we have going on here? Taking a small quick break from proofs. And let's see here. We have 2 lines that cross. The only thing remotely related to what we just did is the vertical angle congruence theorem. It says vertical angles are equal, or are congruent, which means they're equal. So let's see here. Let's do 13y. Which angle is vertical to the 13y? That's like the top left. Opposite that is the 10y plus 24. Those 2 angles must be equal in measure. So set them equal and solve. Subtract 10y from both sides. 3y equals 24. Divide by 3. Y equals 8. Do we have any more vertical angles? Yes, we do. Those 2, the 2 stars, those are vertical. They're across from each other in this picture. So we can set them equal to each other. 5x plus 11 is equal to the 4 parentheses x plus 6. Now we solve. So we have parentheses on the right side. That means we need to do this, which is called distributing. We need to distribute that 4, which turns into 4x plus 24. Now I'm going to subtract 4x from both sides. Get x plus 11 equals 24. And then subtract 11 from both sides. X equals 13. If you're ever in a situation where you want to check your work, you can always plug x back in to both of these and see if you get the same answer for both. They should be equal when you plug them in. Now proofs. I love proofs. I love the problem solving and the thinking through it, organizing my thoughts, writing them down. So we're going to do a 2-column proof, and then we're going to do a flowchart proof. I do have an additional piece of paper here for the flowchart proof, just so that I have lots of room to do it. Sometimes they take up a bit of room. If you are short on paper, 2-column proofs sometimes are a little faster in that sense, less paper. So let's see here. We are given that ACB and ACD are supplementary, and we are given EF, EGF, and ACD are supplementary, and we're trying to prove that angle ACB is congruent to EGF. So this whole proof is this one here. We're going to prove this theorem. We have 2 things that are supplementary, and we're trying to prove some congruence at the end. Same thing, but we're actually going to go through the whole proof. So let's do the 2-column first. Statement, reason. All right, what's the first statement we should use? Well, given always comes first. So line 1, angle ACB and angle ACD are supplementary. And how do we know that? It was given. Great. They're supplementary. So what? What does that mean? What does that tell us? What can we conclude once we know that they're supplementary? Well, going back to your Train the Brain worksheet, where is supplementary stuff? Number 10. If two things are supplementary, that means their measures add to equal 180 by definition of supplementary. So number 2 reason is definition of supplementary. Number 2 statement are that these measures, the measure of angle ACB plus the measure of angle ACD, is equal to 180. Now that's all we can conclude at the moment. So if in doubt, go back. Are there any other givens? There is. Let's use that one and see what happens. Angle EGF and angle ACD are supplementary. Given. Well, now line 3 says they're supplementary. So we're back here. If it says, if you ever put down in your proof that they're supplementary, this is either coming immediately before or immediately after, and it's probably immediately after. So, line 3 says supplementary. The reason for line 4 is definition of supplementary. Pretty much guaranteed. Statement 4 is very, very similar to statement 2, except we need to use the new letters. The measure of angle EGF plus the measure of angle ACD equals 180. So far, so good. We wrote down the 2 givens and we came up with 1 line from each of them. So let's look. Line 1 gave us line 2. Line 3 gave us line 4. We already used line 1. We already used line 3. Let's look at 2 and 4. So ignore everything else. Ignore line 1. Ignore line 3. Just look at 2 and 4. Do you see anything there? Anything that would allow us to connect 2 and 4? Well, I see they're both equal to 180. 180 and 180. And when they're both equal to the same thing, that's number 13 on our Train the Brain paper. I told you we'd be using this paper a lot. Save, save, save. When they're both equal to the same thing, that's the transitive property. Let's use that. Transitive property. P-R-O-P for property. And the transitive property allows us to remove the part that repeats. So the 180 and the 180, that's the part that repeats. So let's see here. Let's put the measure, this part, which is equal to 180, equal to this part, which is equal to 180. So the 2 parts in the rectangles are now equal. Measure of angle ACB plus the measure of angle ACD equals the measure of angle EGF plus the measure of angle ACD. All right, this is normally where I start to get a little confused. There are a lot of letters there. There's a lot going on there. So let's look at where we're trying to end up. I said sometimes it's easier to work from the beginning, sometimes it's easier to work from the end. Let's look at the prove. Remember, the prove always goes last. So angle ACB is congruent to angle EGF. That's last. Has to be, because that's what we're trying to prove. Now, we don't know the reason yet. We're just trying to kind of put some pieces together. So there's kind of a big difference between line 5 and this line. We kind of switched languages. So here you see line 5 is equal, and this one's congruent. And line 5 has M's, and this one doesn't. So somehow we switch from M's and an equal sign to no M's and a congruent sign. What allows you to switch between equals and congruent like that? Train your brain. Number 1, congruence can change to equal by the definition of congruent. So, sorry, not line 1, line 6, because we're dealing with angles. Same idea, still definition of congruent. It allows us to switch from the measures being equal to the angles being congruent. So the line right above this would have had to have been measure of angle ACB is equal to the measure of angle EGF. Right? So if they're equal, that means they're congruent. So let's go backwards again a little bit. How do you get from 5 to this? What changed? Measure of angle ACB, measure of angle ACB. It has this measure of angle ACD, has that. On the right side, measure of angle EGF, measure of angle EGF. But look, it also has a measure of angle ACD. So between here and here, what changed was that these purple boxes disappeared. They went away. Well, that can be done in one step because they're the same. What happened? How did we get rid of it from both sides? Subtraction property. We subtracted it. Then, do you remember what I said? What allowed us to go from equal to congruent was the definition of congruent. And that's the proof for the theorem. Let's do the flow proof. So flow proofs are boxes and arrows. So they go left to right, just like you read. Some things to know. Every given gets its own row. That's like its own new level to the proof. So let's start. A box. Statement goes in the box. Angle ACB and angle ACD are supplementary. Underneath it goes the reason, which was given. Now, what could we conclude from line 1? What did line 1 tell us? Well, line 1 told us line 2. Right? We knew that these equaled 180 degrees because line 1 said they were supplementary. So, line 2 connects to the box from line 1. The measure of angle ACB plus the measure of angle ACD equals 180. And the reason, right here, same reason, definition of supplementary. Now I'm not going through the whole proof again, I'm just going through how to get from here to here. We already know why it works. We already went through the proof. You don't need me to explain it again. If you want to see it again, just rewind the video and watch it again. I'm just going, how do you get from a 2-column proof to a flow proof? Now line 3 was another given. This information up here, line 1 and line 2, were irrelevant to line 3. A different thought. Each given gets its own line in the proof, its own row. So, next given, angle EGF and angle ACD are supplementary, and the reason is it's given. That was line 3. Line 4, measure of angle EGF plus the measure of angle ACD equals 180. How did we know that line 4 was true? Well, we knew line 4 was true because they told us line 3. So it comes in your flow proof off of line 3. The measure of angle EGF plus the measure of angle ACD equals 180. And the reason, same reason, definition of supplementary. Given what it told us, given what it told us. Now line 5 is a little tricky. Line 5 was where we used the transitive property to put line 2 and line 4 together. So line 5 was where line 2 and line 4 came together. We used 2 and 4 to make line 5, which means in your flow proof you need to use both of those boxes to get to your next box. Both of these were used to create line 5. Line 5, measure of angle ACB plus the measure of angle ACD is equal to the measure of angle EGF plus the measure of angle ACD. Please, please, please write as legibly as you can. Give yourself lots of room underneath it. The reason, transitive property. Now from line 5, we use the subtraction property from line 5 to get to line 6. But we only used line 5, which means in our flow proof, it only comes from that one box. Line 6 was the measure of angle ACB is equal to the measure of angle EGF by subtraction property. So line 5 gave us line 6, and line 6 took us directly to line 7, which was that angle ACB is congruent to angle EGF. And the reason, definition of congruent. So a flowchart looks very, very different than the 2-column proof. 2-column proof to me, I always thought it looked more professional because it's something that I could imagine, presenting in a paper or something like that. This one though, the flow proof, actually is something that you could give to people, and I think they could follow along because of the arrows. People know how to follow arrows. So they could actually tell what thoughts are coming together. It could be a really useful way. Now, some people prefer the flow, some people prefer the 2-column. It's really up to you, except you do need to be familiar with both because both will be required or could be required on the final exam. So make sure you are able to do flow proofs and 2-column proofs. My argument, though, is that if you can do a 2-column, they're the exact same words going into the flow proof. You just get to kind of make it more picture-like with arrows and boxes and lines. Let's try example 3. Again, the more of these proofs you see, the better off you will be. So we want to practice lots of proofs so that when it comes time, say, for your homework or for the final exam, it's nothing new to you. You've seen the proof or one almost identical to it. In example 2, they were supplementary, so maybe on the final they would be complementary. It's almost the exact same proof. So example 3, given measure of angle 1 is equal to measure of angle 3, prove the measure of angle EBA is equal to the measure of angle CBD. Statement, reason. In line 1, that nobody's going to miss this one, line 1, given. And the given is the measure of angle 1 is equal to the measure of angle 3. Great. Now look at where we're needing to go, though. We're needing to go all the way to measure of angle EBA is equal to the measure of angle CBD. So where is EBA? Why did I jump to the prove? I jumped to this part because I don't know where to go after line 1. When I put this one down, there's nothing obvious to me. The only thing that I would obviously do to this would be to turn it into congruent. But that doesn't seem right because there are no congruent signs in this proof. So because of that, because I don't know where line 1 should go, I'm going to look at the end and try to figure out where should I be going? Which direction should I be heading? So we're heading toward EBA equaling CBD. We're trying EBA, that's these two pieces, the 2 and the 3. CBD is the piece 1 and 2. So we're going to have to somehow create EBA and CBD. So how do you create something that's 2 pieces? Well, on the Train Your Brain, was there something that allowed us to take 2 angles and combine them into one? Number 7, angle addition postulate. So let's see here. I don't know, let's use 1 and 2 first. The measure of angle CBD is equal to the measure of angle 1 plus the measure of angle 2. And that's the angle addition postulate. Well, let's do the same thing with angle EBA and see what happens. The measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 3. And I'm actually going to put the 3 first. And the reason I'm going to put the 3 first is because we eventually want to show that line 2 and line 3 are the same. And when I line them up like this, do you see the 2's are the same? The problem is that the 1 and the 3 are different. But look at line 1. We still haven't used line 1. Line 1 says that the measure of angle 1 is equal to the measure of angle 3. So what we can do, I don't know, let's take this 3 and turn it into a 1. That means the measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 2. And how did we change the 3 into a 1? We use substitution. Or the substitution property. We substituted, because we knew the measure of angle 1 was equal to the measure of angle 3, we changed the measure of angle 3 into a measure of angle 1. A lot of times when I do proofs, I feel like I'm doing the hidden pictures. If you ever had like highlight magazines or saw them in a doctor's office or whatever, they have hidden pictures and you're looking for secret things, or you're looking for what part of the picture changed. Things like that. What makes it the same? What makes them different? I'm looking for those sorts of things as I do these proofs. Do you see the measure of angle 1 plus the measure of angle 2? This one is the measure of angle 1 plus the measure of angle 2. We have two lines, line 2 and line 3, line 2 and line 4, where the right sides are exactly the same. That's number 13 on the Train the Brain. Transitive property. If you have two things that are equal to the same thing, you can basically get rid of the repeated part and make the stuff equal. Get rid of the middle part. So here, because they're both equal to measure of angle 1 plus measure of angle 2, we can actually make the measure of angle EBA equal to the measure of angle CBD by the transitive property. Now where do we go from there? Sometimes if you can't figure out where you're supposed to go, it's because you're already where you belong. Look at line 5. Measure of angle EBA is equal to the measure of angle CBD. We're done with this proof. You see it? What did I say? What you're proving always goes in the last line. We got here without even exactly knowing we were there. But this proof is in the last line, so our proof is done. Let's do the flow chart for it, and then you can go ahead and work on your homework. So what did I say? You start with a given. So let's see here. Put this over. The given measure of angle 1 is equal to the measure of angle 3, which was given. Now line 2, though, was not a given. It used the angle addition postulate, but I mentioned it earlier. Angle addition and segment addition are kind of ones that we just got from the picture. It didn't come from the given. It came from the picture. So they actually get their own line. The measure of angle CBD is equal to the measure of angle 1 plus the measure of angle 2. And we know that by angle addition. And we also know that the measure of angle EBA is equal to the measure of angle 3 plus the measure of angle 2 by angle addition postulate. Now, we use substitution next, and we substituted line 1 and line 3 to get line 4. The issue with that in our flow proof is that we're going to have to connect this substitution with this one. And when you connect that, we're kind of blocking this one off so it can no longer become really part of the proof. So this given, in order for me to be able to flow in the flow proof, I'm going to move it down here. Measure of angle 1 is equal to the measure of angle 3 was given. And now these two combine together. By substitution. These are the two, in my 2-column proof, these are the two I used. Then, these two came together and said, the measure of angle EBA is equal to the measure of angle CBD by transitive property. Now you could reorganize it. Maybe you don't like this box with the long, awkward arrow. If you wanted to make your proof, if you had planned ahead, you could design it like that. It's the arrows that are connecting it. So if you don't like that big long arrow, make your arrow shorter and pull that box together. If you're not planning quite ahead as much as I didn't plan ahead, obviously. I even had to move this box. But, if you have a big long arrow, if you have a box scribbled out, that's okay. If you run out of space on your proof and you have to do like this sort of thing, that's okay. That's why we have the arrows on it. Go left to right. If you run out of room, loop back around. If you have just one box left, you can just put it down here. If it's just one box, make sure you're practicing flow proofs. We're going to use them a lot later this semester.